So, so we are going to learn about diabetes today, and then we will see the other parts in the next class. I think the paper is already uploaded. I would want you to have a look at it with the same title you will have. Please try to read the paper, and then we will see. So, in all these papers, we are trying to read mostly about the about the genetic manipulation and some of the molecular techniques. Okay. So first thing, diabetes. I guess now you are in fourth year, so you must have read this before multiple times. But then let's just go slow anyway. Diabetes, you have two types. One of it is mellitus, and the other one is diabetes insipidus. Insipidus is it's too much of urination and so on, and because of lack of vasopressin. That's a different disease. What we are concerned is about diabetes mellitus, which is the characteristic of it is hyperglycemia. That means there is high blood sugar, that is hyperglycemia. Again, diabetes is divided into type 1, type 2, and there are the type 4 gestational diabetes is also there. There are many other not so popular, but there are defined diabetes which we are not going to discuss, but we will look into some of these things. Okay, we are now trying to understand the nature of disease, and while doing so, we will, after that, or so along with this, we will try to learn about the tissue, that the functional tissue, and then we will try to build a tissue that functions similar to the normal one. Okay, and that is the whole goal of this approach. So type 1 diabetes is because of insulin deficiency. There is a loss of beta cells. If beta cells are destroyed, then beta cells in the pancreas are the ones that produce the insulin, and if they are destroyed, there is insulin deficiency. In type 2 diabetes, it is insulin resistance. Sorry, primarily because the insulin is present enough in the blood, but the target cells are now resistant, because of which they are unable to take up the glucose. We will see all these in detail. This is just an introduction right now. And there is also one more called as gestational diabetes, which happens during pregnancy in some. So diabetes 1 is type 1 is less common, but the point is that the insulin producing cells are destroyed. So all the beta cells are destroyed, all the blue ones gone. That could be because of viral infections, or sometimes some people may be genetically predisposed to become where the beta cells may die out sooner, or less half-life, you can think of it. Or mostly I think it is a kind of autoimmune disease, because of which the immune antibodies produced may have specificity to beta cells, because of which they might be killed. I think this is a popular, or mostly that is what is usually present. So as a result of which, either any of these could be the reason, but the point here is there are beta cells are dead or very less in concentration, because of which the insulin production reduces. And in type 2 diabetes, let's say the normal condition, what happens in general, and then probably you'll make sense. Anytime there is glucose in the bloodstream, right after a meal, we have digestion, and then the glucose and other things are absorbed by the intestine and then transported to the blood system. and in this through circulation it moves along, and these the glucose and other things should be taken up by the different target cells, mostly the liver and skeletal muscle cells and so on. And for the target cells to take up this blood, take up this blood glucose, they need to be signaled that there is high amount of glucose now, so you should please take. In that case, what may happen is, what happens usually is insulin is produced in response to high blood glucose after a meal typically. Once the insulin is produced, the target cell becomes activated and then will take up the glucose. We have transporters called GLUT4 and all. We will discuss those in the coming slides. But what happens in type 2 diabetes is, even though there is insulin and the insulin may not be able to bind, it's not in type 1 there is no production of insulin, because of which the cells are not taking up the glucose, because of which the blood glucose is increasing. Whereas in type 2, insulin is present, but somehow the cells are not responding to the presence of insulin, and because of which glucose is not taken up by this target cell, and therefore the blood glucose increases. And the gestational one is during pregnancy, in the first or second trimester or so, the blood glucose increases high, and that is thought to bring a lot more glucose to the baby than normal individuals, and because of which the baby will take up a lot of glucose and then will have an extra weight. And usually nowadays it has become a common practice to test for blood glucose in pregnant women, just to ensure if the baby overgrows, then the birth becomes difficult. Then it may pose a problem to the mother as well as to the child, because during delivery, if it has to come through the birth canal, there might be a lot of trouble. With cesarean, there are nowadays it's not that complicated, but still, I think one has to keep monitoring to avoid any adverse effects and so on. So the insulin is produced by beta cells, and beta cells are present in pancreas. Pancreas is kind of hub to maintain the blood glucose, or the general metabolism, or how the food is taken up and stored and distributed throughout the body in a way. So it has several cells. We are not going to discuss all, but it's a good idea to learn some things little bit here and there around what we are learning. So alpha cells that are responsible for secretion of glucagon, beta cells, that is what we are actually studying, that is important for secretion of insulin, and delta cells, they are involved in production of somatostatin. There are exocrine pancreas, and then the F cell that secretes pancreatic polypeptide and so on. We will mostly focus on these three. I mean, this is the one thing, insulin is beta cells, and insulin production is what is our actual objective in this particular lesson. So glucagon, insulin, and somatostatin have kind of related functions in a way. First, glucagon is involved in glycogenolysis. Glycogenolysis. That means it will break down glycogen to glucose in different cells. That's what it does in liver and muscle cells, skeletal muscle cells especially. Glucagon will allow the production of glucose from the stored carbohydrate glycogen. And in plants, you can store it as starch and other things. In animals, it is glycogen. And there is so actually what is glucagon doing? It is increasing the blood glucose. okay, from inherent glucose. What I meant by that is, so when food is digested and from intestine glucose is taken up, blood glucose increases, that is taken up by the cells, and that job is done by insulin. And insulin also does something else, that it will allow glycogenesis. You need to keep those terms in your mind. Glycogenesis is production of glycogen from glucose. So it's actually the reverse of this reaction. Insulin does this uptake of glucose by the target cells and production of glycogen. That is glycogenesis. What glucagon does is the reverse of it. Glucagon, it breaks down the stored glycogen and allows the production of glucose, which might be secreted into the blood, and that could be transported to different cells for consumption. And so these two are kind of antagonist in several ways, right? So you have to remember these two functions. Glucagon is produced by alpha cells, and insulin is produced by beta cells. Islets of Langerhans and other things. I guess you know those stuff. So there is also a kind of coordination between these cells, when which cell should be produced. Say if glucagon and insulin are produced at the same time, it's not a good sign, good thing for the body, right? The one is confusing the cells what to do and what not to do. That's actually going to be a difficult situation. So there is kind of coordination when alpha cell secretes, it produces insulin, and that insulin may activate delta cells as well as beta cells. And beta cells, when they activated, they kind of inhibit the glucagon and allow the production, release of, so insulin that is produced, it has inhibitory effect on glucagon and will also enhance the uptake of glucose by the target cells. Okay. So what I want you to understand it is, there is a coordinated function. It's not like they just are released anytime. That's not the case. Type 2 diabetes is little more complicated than what we think as just as insulin resistance. It has two phases. The first one is called as insulin resistance phase. I think we all have to also remember that in our daily life, what we do, we wake up, say around 7:30 or so, we have breakfast, right? And then around somewhere around 1 p.m., we have our lunch. They are the biggest meals of the day you can think of. And around say 8 p.m., we may have dinner, right? I want to compare with what would have happened if we were in our ancient days, like just like animals. What does a wild animal do? Say if we were wild humans, what would we be doing actually? We had to work hard for our breakfast. That means we would have gone hunting, right? And then that hunted food, we would have foraging or hunting. We would have spent a lot of energy to get food. Again, food is energy. Okay, there is a balance between energy spent and energy produced, and again energy spent, right? That means we have a majority of the animals, wild animals, have a routine of hunt. Okay, we have stretch, hunt, eat, and sleep. This is the typical routine. We, because of our science and technology and many other our civilizations and so on, we now don't have to physically hunt for stuff. We don't have this part of it. We rather now realize the importance of exercise, and then we spend the energy that way. But typically, I think this is the routine we had: hunt, eat, sleep. Okay. And coming to our actual daily life that we have now, we have breakfast, lunch, and then dinner, and then in between snacks because they're available. Snacks again because our friend brought a chips packet, or there was a break in between, so we went to CC or Bombay Sweets and bought something. We are again going to eat something in between lunch to dinner because we are bored. And this is my schedule actually. I don't know if it is yours or not. So we have so much of eating. That means we have so much of calories that we take in, and we don't spend it. Spending is not there. For you people as youngsters, your metabolic rate is high. Therefore, whatever it is there, you will generate in terms of your activity or heat and other things. Once people reach about 30, 35, the metabolism starts going down. And that is when anything that is eaten is it starts to accumulate in our body. And then we may have health issues or excess weight like obesity and other things. And eventually we might fall ill to diseases such as lifestyle diseases, which also includes diabetes, right? So what I'm trying to say in this particular slide here is, here after breakfast we have food, so insulin is secreted. After lunch, and in all these cases, anytime you have eaten and digested some food, one is going to have insulin secreted. So if you are talking about the wild human type, okay, wild human style, say at any given lunch or breakfast, it is only thrice a day or something like that, or say twice a day, and assume that it is going to be some 10 units of insulin. Okay, I'm just making up stuff. Now let's compare to each time you eat, it's going to be 10 units of insulin. Okay, think of it like that. Now, if we compare with our own body, our lifestyle, we eat so much food: 10, 10, 10. Everywhere, 10 units of insulin is being secreted all throughout the day. So it's kind of the target cells become resistance to 10 molecules of insulin. And then because these target cells have become resistant to 10 units, blood glucose increases. That means more insulin is produced. So maybe 100. And then maybe you might take up little glucose. So now your target cells are responding to 100 units of insulin in relative to which would have been 10 units of insulin. So we are actually creating this resistance in our cells by overeating and spending less. And we are eating calorie rich food. It's not normal food, and we don't spend energy to get that food. So say after a while, the target cells become resistant to even 100 also. That means the insulin should be 100 units for them to be responding. And imagine this way: the beta cells are continuously doing that stuff, and then there will be exhaustion of beta cells, and then they undergo apoptosis. Okay, the first phase of it is insulin resistance, that is caused due to less amount of energy spent. In general, I'm talking about daily life, less workout and more high calorie rich food, and frequent ones, because of which the target cells become resistant to insulin. After once that continues for a while, there is insulin deficiency because the beta cells now are overworking and they might undergo apoptosis. Okay, so those are the two parts of type 2 diabetes. There are, it is multifactorial. Some people do not get, some people get, and it is to do with some genetics as well. Some families are much more prone. I think Indians or South Indians, I think, are much more prone to diabetes. There are also epigenetic mechanisms involved. Apparently, if I read the report correctly last year or before, 2 years back, when in pregnancy, when we are in the womb, and if there is vitamin B12 deficiency, those people are likely to have diabetes, apparently. Okay, so that might be another story altogether. So, um, the symptoms of diabetes include several things. Eventually, the body is not, the muscle cells and others are not getting enough glucose. Then it will start to eat itself and become, the muscle tone is lost, and there will be systemic weight loss, because the cells are not depending on normal metabolism and maybe undergoing gluconeogenesis and other ways pathways. There might be metabolites that are released which may give the smell of acetone when we are doing it. And then polyuria, that, and glycouria, where the kidneys will work hard to get rid of majority of the glucose, and because of which one has to go for urination multiple times, because you're urinating often. You have to remove glucose, that's why you're urinating more. Because you're urinating more, you feel a lot of sense of thirst, and also hunger. So that is how many things are involved. And then it will, there are multiple organs that are going to be affected on prolonged high blood glucose. What is this? They are called as diabetic cardiomyopathy, diabetic nephropathy, periodontal diseases, diabetic retinopathy, and encephalopathy. Almost all these are essential, or kind of, they reduce the quality of life when these things are affected. These organs are affected. We'll see a few. First thing is diabetic retinopathy. This is how normal eye is. This is the retina that is here, and we have the blood vessels that are there that are supplying blood to the retinal cells, cones and rods. And in a diabetic retinopathy, what may happen is there are two complications. One is hemorrhages, that is breakage of blood vessels and leaking blood. And the second thing also would be microaneurysms, that is formation of fine new multiple blood vessels and kind of swelling little bit. So what I mean to say is the retina that is here is usually not going to be the same um, in this case. Okay, just so the retina will have will cause, and what may happen eventually is this is how it will look like. The person, a normal person would see something like this, whereas in a diabetic retinopathy there will be black patches, which are the obstructions caused by aneurysms or hemorrhage and so on. Okay, these are kind of extreme cases. Usually it is in a very older age, after 65, something like that. But otherwise, until then, we do have enough physical activity to, or the damage is rather slow. And there are many other things, as I was talking about. One of the things that we want to talk about is extremity amputations, right? So, in diabetic patients, what may happen? There are two problems that are there. One of it is reduced blood flow through the blood vessels in the extremities, like feet mostly, and eventually that also results in the damage to the nerves, because of which there is a condition called as diabetic foot. Okay, The cause is simple. The If there is no supply of oxygen and food materials to the extremities like feet, then there is going to be less of uh, less of cells, active cells, and the important is the repair is not so well. You need oxygen for metabolism and the life in all the cells, and also to repair any damaged cells, so to get rid of debris and many other things. So if there is a situation where there has been a blood clot somewhere around here because of narrowing blood vessels, all the downstream tissue that was receiving blood from that particular artery would now become anoxygenic or hypoxic, and eventually the tissue will start dying. The tissue typically would look, some parts in the bottom of the feet, they do get all this tissue is dead because it's not receiving blood anymore. And feet are the one thing that is, feet are some things that are taking the whole weight of the body, isn't it? So they are under a lot of stress, and they are likely to also get hurt and other damage. So in severe other conditions which may happen is something like this. So all this tissue is necrotic, it becomes blue. I mean, apoptosis is cell, and that cell becomes into chromosome fragmentation, everything, and blebs like this will form, which are cleaned up by the macrophages. But necrosis is something like this, it just pours out everything that is here, and then the cells are dying out, and then this is irreparable. And if untreated, it might cause much more complication. It is complication because there is no supply of blood to this. That means there is no repair, there is no inflow of blood, the phagocytes and other things to clean up the mess. So, and if you have something dead here, the other tissues also might be affected gradually. So there is only one way, is to amputate. The amputation should happen if, based on where you want to, say, if this is the place where the clot has happened, where should the amputation be done? This is the tissue that is dead. Should be cut here, 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 or here. The place is determined by until where is the blood flow good. If the blood flow is good till here, that is where you should cut. Amputation. I mean, that is because you need, after amputation, we need so much of repair to be done. And that is the basis for it. I hope you also realize that, see, they have covered up the skin in such a way that the amount of wound to be healed is also less, so that hopefully the lesser the new tissue or to be formed, the better it is, healing will become faster. But I hope you see the problems with these. I don't know, nowadays it's a very common to have parents or grandparents who may have had diabetes or come to a situation like this. So there are two things about diabetes. One of it is, it is pro-angiogenic in some tissues and anti-angiogenic in some other tissues, right? In the in diabetic retinopathy, we have seen that there is hemorrhage or blood vessels forming and so on. Whereas in extremities like in the feet and so on, we see that the blood vessels are narrowed down and the supply is actually lesser, and they don't form new, angiogenesis does not occur. So in different tissues, angiogenesis has, the angiogenesis because of diabetes changes. Say in retina, kidney glomerulus, and in cancer and other plaques and so on, you have more of angiogenesis forming. Whereas in tissues like heart, kidney tubules, wound repair, and other peripheral vessels and placenta, the angiogenesis, it is anti-angiogenic. So these two are one of the some of the things that we need to keep in mind. So what to do for it? If it is type 1 diabetes is due to lack of insulin. And in that case, it's not something we could have managed without injecting insulin. We should have injected insulin. If it is type 2 diabetes, it is because of insulin resistance. And then, of course, eventually it is insulin, lack of insulin, but that's not the problem right away. Insulin resistance is the problem. At least this one is kind of in our habits other than the genetics. We will not talk about the genetics because that's not in our hands. What we can do is how we can maintain our metabolism. If I didn't tell you this before, I will tell you now. One thing you have to all remember is, so 15, say until we will call is 15 to 35, and then say 65, and so on, say 85. I'm talking in terms of years and age. From here to here, apparently the metabolic rate is usually very high metabolism, and it slows down around from 35 to 50 or 45. It starts slowing down from 30 onwards or so, and then something like this, and then we have to struggle hard to keep it up well. The quality of life one has during this time, um, how active one remains in this life, will determine the quality of life in the later part of the age. So it's important that all of us have set a degree of activity. When I say activity, it should be strenuous physical activity, like playing games or exercise, jogging, swimming, any of those. At least it is, I think there is a nice course on Coursera. It's called The Science of Exercise. If possible, you can try to do it and learn a few things. It's a short course. So I think, if I remember correctly, it says, I think you need weekly thrice. Weekly thrice, you should have physical activity. And please remember this, how active you remain in this age is going to determine how well you can lead a life afterwards. Okay? And there is not much actually after this. Okay? It's responsibilities and responsibilities upon responsibilities. This is the most passionate life. In that part of the life, one has to include um, just not just about caring about what others feel about you or think about you. It is about what you think about you also, what you can do for you. I think that's how you can approach and try to motivate yourselves to have and include uh, physical activities. I understand that we are kind of conserved society, and still we have to break some those kinds of norms and try to stay physically very active. So in type 1 diabetes, this is only solution is to give insulin. How much to give, when to give, those are some of the problems, isn't it? I think in one of the assignments I have given how to produce insulin. I hope you all have done that. But that is an important uh, uh, question that might come for end semester exams. And I will discuss about end semester exam later. And in type 2 diabetes, we have to increase our daily routine of, you as youngsters, you don't feel this at all. But once you cross 30 or so on, the people will know at that time they may feel, especially if you are genetically predisposed. If your parents, if both your parents have, there is 58%, I think. If both your care on both side grandparents have, there is likelihood that we will for sure get. So there is little bit of those things you have to remember. So have exercise at least weekly thrice. And there is one more thing. I will stop after telling this, or one more. So this is daytime. Say 6 a.m. to 10 p.m. Right? So you should have adequate amount of sleep. I think we are all becoming nocturnal as time progresses. There are class A and class B. Class A are early to bed, early to sleep. Class B are late to bed, late to wake up. I belong to this, but not now. Previously, I belong. Occasionally, I do indulge in myself in this, but this is usually the healthy habit is class A. We're all tuned to the production of, our circadian rhythm is based on that. That's not what I'm talking about anyway. The point is, if you sit all through the day and just in 1 hour you're going to exercise, say 1 hour, compare a different lifestyle. You have this same lifestyle. Only thing is you're working here, you're working out, working out, working out. Small little bit of the whole day. So this is a better lifestyle where the body should keep moving well enough, if not very rigorous. And this is a much healthier lifestyle than this one. So try to avoid sedentary lifestyle. Don't sit for too long. If you're sitting for too long, go and take a break and get. I understand that in modern life that is not possible. I can see it myself too. So, but try to include, keep yourselves informed of these kinds of things. Okay. I think jogging is good. Running, yeah, jogging, swimming is better. Um, but otherwise, I would prefer games. Games are the best solution for these things. So try to. I'm hoping that you will all have a very active life during this period, and try to have mix of both, an active lifestyle and also including one amount of stretch of games. And games or any strenuous exercise will produce myokines from our skeletal muscles, which are going to influence our brain. They'll keep our mood up. They will attention span increases, focus increases, the general mood increases, and happiness increases. So those are the ways of how we can actually try to better our lifestyle. Okay. So there are many other. I will just take this and the next slide and stop. There are other medicines. Allopathy is actually, you can say, modern medicine, or how you would say is mostly you call it as evidence-based medicine. So there are, it is effective, and there are side effects. I think that is what will happen. There are alternate medicines, alternate medicine, which people, many cultures have it. There is Ayurveda, Siddha, Unani, and you can go to Africa, and Africans have their own kind of medicine and so on, which is transferred from generation to generation. Uh, I mean, it's all dependent on how you see things. Okay, we need to, unless homeopathy is there. So there, many of them claim to have no side effects. That is the selling point of those in most case. But we have to be careful about, no side effects is fine, but are they, is it effective or not is the question. In some kind of traditional medicines, they use heavy metals, I think, and which may actually cause, may cause temporary relief, but in the long run they may cause serious damages. So try to read about the literature, read both sides of the things. I'm not saying what is right and wrong. I'm saying how your approach should be, and you try to look into those stuff and say. So in modern medicine, there are several compounds like bigonide, TZT, and so on. So they will reduce here. This is going to block the release of glucose from liver. The point is to reduce the amount of glucose in the blood. So for that, you can increase the production of increase the production of insulin by using compounds like this. Reduce the uptake of glucose. This is probably a good one, so that we will not get fat. We can eat all we want but not get fat. Just kidding. There are also other molecules which will increase the uptake of glucose, like similar to that of activity of insulin. Adipose tissue release of free fatty acids from adipose tissue is also reduced. So there are no medicines that we know of in alternate medicines, if we can think of, that can reduce sugar as such. Say many propose there is a treatment for cancer, there is a treatment for diabetes, there is treatment for everything that we say. But where one has to, with science, you have to approach, take into account the evidence, what is available, and you read the papers and see, and then adjudge whether it is right or wrong. If the tests were experiments were done well or not, are they statistically significant or not, and then use your critical thinking without any biases, and then try to take. Are we biased or not is one question that we all have. Say if I take tulsi waters, tulsi leaves, I do take pepper, maybe turmeric, things, but I actually don't know how they actually, what interacts with what. That is one of the problems we have. And I like to take those kinds of things because my grandmother told me. Okay. Probably she learned it from generation from there on, so on. But if I have to support this, the alternate medicines, but there are so many other alternate medicines from every other society. Are we willing to try those? No, I wouldn't do that. I am biased towards what I have learned from my grandmother, because it's my grandmother who told me, and it belongs to my culture. It belongs to, we put in a lot of bias there, right? So in, when we are trying to deal with any issues that are serious, of high importance, especially medicine, medical health conditions, and so on, one has to take a very unbiased or objective approach to deal with it. Okay. So here is what is required for an ideal therapy. So the ideal therapy should be able to replace the damaged tissue, should be like almost like putting beta cells that will produce insulin. And the reason for that is to, I'll just, this is normal thing. First thing, any cells I'm putting it should be able to secrete insulin. And insulin is produced as a single polypeptide and then processed to two polypeptide chains, right? Bound by disulfide bonds. We will see that in the next class. So that cell should be able to process the insulin. Second is, insulin should be produced, the cells should produce insulin only when the blood glucose is high after a meal. Okay, it should be able to sense the blood glucose, not that all the time if it puts out insulin, that is going to be a problem to the body. So there should be secretion, timely secretion of insulin, and once it is triggered to secrete, there should be also a stop, right? That is one more thing. The cells that we are putting in the body should live for a long time. It's not like we put cells for, and repaired cells to produce insulin, and those cells died in a year. Again, we have to take and put it into the body. That's going to cause a lot of problems, right? So these two are related. And the another important one is that the cells that we are putting in should not interfere with any other functioning with the coordinated with the rest of the body, and should not interfere with any other the functioning of any other cells. These will be the challenges that we have to overcome if we want to try to, sorry, sorry, if we want to um, take a regenerative medicine approach, which will include cell biology and gene therapy kind of approach. Okay, I'll stop here. Any questions? Akshaya, can you please quickly ask the question? One question, maybe.
Sir, I don't have any question.
Not this. Other ones you said you had.
No, sir, you had asked me if you were audible, so I said yes.
Oh, okay, okay.